Okay, let's try a few more graphs. So this time we've got y equals 1/5 to the x. Again, it's an exponential function because you got the x up here. It's exponential. Y equals a times b to the x. So our a is just 1 here. So remember, our initial value, a is your initial. So when x equals 0, our y is going to equal 1. And this time, 1/5. 1/5 is less than 1, greater than 0. So this time, instead of exponential growth, we're going to have exponential decay. B indicates we're going to have exponential decay. So we'll see what the difference is there. Let's go ahead and let's just label the same thing, -2, -1, 0, 1, and 2. All right, let's do a t-chart again. X and y, so -2, -1, 0, 1, and 2. So this time, if I plug in 1/5 to -2, this one's a little bit more interesting. So 1/5 to the -2. 1/5 to the -2, what does that mean? Well, let's just rewrite that. 1 to the -2 over 5 to the -2. So that means you have a negative negative exponent up here, so we can send that guy underneath. And you have a negative exponent down here, so you can send that guy up here. Basically, they're going to switch because this guy's negative, this guy's negative. So the 5 squared is going to come on top, and the 1 squared is going to come underneath. Basically, you're just going to get 25. Okay, same thing here. -1, so 1/5 to the -1. 1/5 to the -1 means 1 to the -1 over 5 to the -1. 1 to the -1 over 5 to the -1. So they're basically going to switch. The 1 to the -1 is going to come down here. The 5 to the -1 is going to come up there. And you're going to get 5 to the first over 1 to the first, or just 5. 5 over 1. Okay, 0. 1/5 to the 0. Anything to the 0th power is just 1. 1/5 to the first power is just 1/5. And 1/5 squared. So that's 1 squared over 5 squared. We don't need to switch them because they're not negative this time. They're not negative, so we just get 1 over 25. All right, so let's take a look at what these would look like. So -2 goes to 25. So how are we going to label these guys? Why don't we just go 25, 5, 10. Let's just go by 5s then, I guess. 5, 10, 15, 20, 25. Okay, a little bit more compact. So -2 goes all the way up to 25. There we go. -1 goes to 5. You can see how quickly we are shrinking down. We're coming down this time. 0 goes to 1. So if this is 5, this is only a fifth of the way up, right there. And then 1 goes to 1/5, so really, really, really close. And then 2 goes to 1/25. Again, super, 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 super close to the x-axis, but not quite touching it. Let's see, that's not going to show up there, so I'll use my purple. So our curve comes down like this. Doesn't quite touch the x-axis. And again, draw in your asymptote here. Horizontal asymptote. Asymptote is y equals 0. So we can see for exponential decay, instead of coming up and shooting up like this, it starts up high and then swoops down. Again, gets really close but never quite touches that asymptote. All right, let's just try one more here. Y equals 3 times 1/5 to the x. So is it exponential growth or exponential decay? Well, we always have to look right here. This is still less than 1, so we still have a b, which is less than 1, so that means that we have decay. The only thing that's different is this 3. So we're going to take all the numbers from our previous one, we're going to multiply them by 3, which also means that our initial value, right, that's what a means, at x equals 0, is going to be 3. So let's go ahead and draw our graph here. Graph. Okay, again, let's do a t-chart. X and y. Okay, so let's do -2. Give myself some space here. -1, 0, 1, and 2. There's some more space. So we're going to have 3 times 1/5 to the -2. We already calculated what that was. That was 1/5 to the -2 was 25. So 3 times 25 is going to be 75. Okay? 3 times 1/5 to the -1. We already calculated that. That was 5. So that's going to give us 15. Basically, whatever output I was last time, we're multiplying by 3 because we got that a equals 3. Okay, 0. Anything to 0th power is just 1. So we're multiplying 1 times 3. Our output is 3. All right, 1. We got 1/5. Sorry, 3 times 1/5 to the 1, which is 1/5. So we're going to get 3/5. Finally, we have 3 times 1 over 25. 1 over 25, which is 3 over 25. Okay, so we can tell we have to get up to 75 here, so why don't we go by, I don't know, tens. 10, 20, 30, 40, 50, 60, 70, 80, and we'll still do this scale here, -1, -2, 0, 1, and 2. Okay, so -2 goes all the way up to 75, way up here, halfway between 70 and 80. -1 goes to 15, halfway between 10 and 20, still super high. 0 is all the way down to 3, so the 0 is only 30% of the way up here. 1 goes to 3/5, so again, super, super, super close. And 2 goes to 3/25, which is also super, super, super close to our x-axis, but not quite touching it because there's an asymptote there. So let's sketch again this curve coming down, 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 to make super close, but not quite touching it. And we have a horizontal asymptote again. Horizontal asymptote at y equals 0. Okay, so we've graphed exponential growth like this, exponential decay like that. There we are.